Okay, this is Unit 6, Lesson 4. I can convert numbers into scientific notation and standard form using powers of 10. All right, so the do now starts you off with a true or false. And usually true or false, kind of easy, right? No, not these. These are not easy. Pause the video right now and go ahead and see if you could answer all of these problems true or false. And we'll be right back. So 6 to the third times 6 to the fifth is 6 to the eighth because you're adding the exponents and keeping the base. You keep whatever is the same. And that is definitely equal to 6 to the eighth. That is true. 2 to the third times 3 to the second, there's nothing the same. Remember, you keep whatever is the same. So really, this does not equal 6 to the fifth power, so this is false. There's nothing the same. You really can't do anything there. So we got 3 to the eighth equals 9 to the fourth. So the best way to do this is to actually just kind of expand it. So if you have a calculator, obviously, I mean, you're going to put this into the calculator and see what's going on here. But 3 to the eighth is this. So it's 1, 2, 3, 4, 5, 6, 7, 8 threes. And then 9 to the fourth is this. So look, 3 times 3 is 9. 3 times 3 is this 9. 3 times 3 is this 9. This. So even without a calculator, I could tell. I don't even know what these are equal to as far as standard form goes, but you could tell exactly that 3 to the eighth power is going to be equal to 9 to the fourth power. And expanded form is always just like a really good way of, just going through things and just seeing if they're equal or not. So just remember, like when you have addition, really, like this is not a law. So immediately it's going to be false. All right, you can check it with your calculator just to see, but you can't add 4 and 5 and get 9 to the third. All right, this is not multiplication, so it's just not going to work. So this one is a little bit tricky. So you have 2 to the third plus 2 to the fifth. And again, I am not going to do anything with that left side, but I am going to distribute here. So the 2 to the third is 2 to the times 1 is 2 to the third. 2 to the third times 2 to the second is 2 to the fifth. And look, all right, it's true. So that's kind of like tricky, but this one's not. So you subtract the exponents, you keep the base, you subtract 12 minus 4. And if you count on your fingers, 12 minus 4 is 8. And that does not equal 5 to the third. And what they did basically is they divided the exponents. So you never divide the exponents. We never did that, and you never do that, and please don't do that. All right, so this explore. Scientists have developed a shorter method to express and we're talking about, scientific notation, very small numbers and very large numbers. All right, you might see this in science. That's why it's called science, scientific notation. Scientific notation is based on powers of the base number of 10. So just make sure that you understand that. Do you know that this number is 300 million? 300 million could be basically expressed using a base of 10. And if you if you really just think about the rules, and I know that some people might not remember scientific notation, but the first number is always this first number. This is a rule right here. The first number must be between 1 and 10. All right, must be in between 1 and 10 to be in scientific notation. So this number right here has to be in between 1 and 10. This number right here is a base number of 10 all the time. And this number here is an exponent. So when we're talking about 300 million, talking about a decimal, which is at this point right here. And you're going to move that decimal to the left a number of times until you make a number between 1 and 10. And right there, if I stop right there, that number is 3.0. And that's 3. And you don't put 3.0, just put 3. And then you just count the number of spaces that you actually move that decimal from the end. And this is 3, this is 4, this is 5, this is 6, 7, 8. So you put an 8. So 3 times 10 to the 8th power is basically 300. It is 300 million. And if you think about 10 to the 8th power, this is what it is. 1, 2, 3, 4, 5, 6, 7, 8. Take a look. 3 times 100 million is 300 million. And that's how scientific notation works. The first number must be in between 1 and 10, and that second number is always a base of 10. The exponent is the number of spaces that you move the decimal. For very large numbers, and you should write this down, large numbers, like 300 million is a large number. That's a positive exponent. Very small numbers, and you know what they'll be like on the next page. You'll see some small numbers. Small numbers, guess what? Negative exponent. So as soon as you see a large number like 300 million, you know it's a positive exponent. If you see a number like 0.036, that's a small number. That'll be a negative exponent, and we'll get into it on the next page. So it says write the following in scientific notation. So I'm going to do A and D with you, and then you could pause the video, and we'll just kind of the answers will appear. It will just give you a chance to do some, just like as if you were in the class. So A is a large number. So this is large. So a large number is definitely a positive exponent. So every number has the decimal at the end of the number. So you have, let me just start moving that because I know I have to make a number between 1 and 10. So I'm moving it. That, if I stop there, it would be 20. If I stop here, it would be 2. So I'm going to put that 2 times 10. And I know it's a positive exponent. It's a large number. So I'm just going to count the number of spaces that I moved. That's 1, 2, 3, 4, 5, 6. And it's 10 to the 6th. And that's it. 2 times 10 to the 6th is 2 million. For D, let me skip to D because this is a small number. Small. So you know that this is going to be a negative exponent. But the first number still has to be between 1 and 10. And you see the decimal is here right now. The decimal is here. So I'm going to move that decimal not to the left, because if I move it to the left, I'm not making a number between 1 and 10. I'm going to move that number to the right. And as soon as I move it to the right, just once, it becomes 1.2498. And yes, that's a number between 1 and 10, and you do have to include all of the digits. And since I moved it 1 to the right, it's going to be -1. Like I said, we knew right off the bat that this is going to be a negative exponent. We knew that the yellow on the top, they're all positive exponents because, again, they are large numbers. Pause the video and try B, C, E, and F on your own. So there are the answers. B is 2.8 times 10 to the 7th. Large number, positive exponent. Move the decimal from the end of the number right here to the 2.8, in between 2.8. And the same thing with C, moving the decimal 10 times to the left to get to 1.99, a number between 1 and 10. Also, the E is a small number. We know that's a negative exponent. I moved it 7 spaces to the right. places to the right, and it's 7.5. I made a number between 1 and 10. And then also the same thing with F. I moved it 3 places to the right, and it becomes 1.0201. You can't round it. This is scientific notation, so that's it. And next page. So this is basically an explore. And, I have on the top, it says positive exponents equal large numbers, negative exponents equal small numbers, and it says write each number in standard notation. So now this is kind of like I'm going to do a couple with you, and basically, hopefully you get the gist of everything here. So this is kind of like going backwards. All right. So we have scientific notation and we have to put it in standard notation. So they want the number that this is equal to. So you really could put this into your calculator and it will give you the answer. But sometimes it gets too large and then the calculator won't give you that answer. But just by hand, it's just like really easy. This is a negative exponent. Negative exponents mean that it's a small number, right? Remember when we say negative exponents, small number, positive exponents, large number. So a negative exponent will always move the decimal to the left, because when you move a decimal to the left, you are making the number smaller. So I'm just going to take this 1.2 and just move it once to the left and put 0.12. And that's it. All right. And this one, it's going to be a small number, and this is to the left again. And only because, it's a small number, it's going to be a small number. So I have 1.2, and I'm going to move it to the left twice, and I'm going to put a 0 and a 0. So you have 0.01. And sometimes when you get like, say you get up to this right here, I'm basically doing all of them with you. I'm going to write this 1.2 down first, and then I'm just going to put some zeros here because I know I'm going to go this way. 1, 2, 3. 0.0012. And remember, when it's 8, -8, this is a very, very small number. So I'm going to start to the right of my page. And I'm going to put some zeros. And when I move that decimal, it's 1, 2, 3, 4, 5, 6, 7, 8. When you rewrite it, make sure you're putting the zeros right underneath, because sometimes you write it wrong. And that's the number. Try the next ones, and remember, the next ones, the decimal goes to the right, because all of them are positive exponents. They're positive exponents, and that means it's a large number. You could pause that video and just pause it, and then when you do all of these, the 4 that are there, just go ahead and unpause the video. Yeah, so the first one is 23, you move it 1 place to the right. Second one is 230, you move it 2 places to the right. Next one is 2,300, you move it 3 places to the right. And this one right here is 2.3, and then I put some zeros in, and it's 1, 2, 3, 4. And just remember, if a teacher ever told you that the number of zeros is the exponent, that's not true. There's 3 zeros here. The exponent's 4, so don't do it that way. It depends on what beginning decimal that they give you, and we're not giving you whole numbers. So that 0 thing, that doesn't work. All right. Explain what you notice about your answers. The positive exponents, they go to the right. The decimal goes to the right. The negative exponents goes to the left. So go ahead, and we're going to refer to the table to the right and order the countries in order the amount of money the visitors spent in the United States from greatest to least. So you're ordering them from greatest to least. And pause the video right now, and we'll be back with the answers. So there are the answers, from greatest to least, and that's about it. Oh, I had it down there, so I didn't put it. This is UK. UK was 10,600,000. Canada, something like 10,300,000. Then you had Mexico and India with the least. All right. So, I mean, obviously, you're going to compare numbers in scientific notation. Go ahead, pause the video again, and then do this whole page, and we'll come back with the answers. When you unpause the video, you'll see the answers. So, pause the video right now, work on it, and see what you can do. So, one thing, I know that the answers are not here. One thing that I did want to say, and I didn't mention on the other page, um, the exponents right here, you can just look at the exponents. You really don't have to write them in standard form. Obviously, a 14, 10 to the 14th is going to be larger to 10 to the 12th. Just watch out though, with this first number. Just make sure that the decimal is like in the same spot, like 6.23 and 8.9. If you move, like obviously, if you're going to move this 14 spaces, like this is a little bit annoying to do. 14 places, I should say. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 0, 0, 0, 0. This is not what they want you to do. Right? They want you to kind of take a look at this, compare this, and if you move this decimal with 14 spaces to the 14 places to the right, obviously this number right here, when you compare this number and this number, which is larger? Well, the first one is because you're going 14 to the right, right? So which is larger? 6.23, even without doing the actual, uh, even without moving the decimal that many places. All right, it could have gave you 6.23 times 10 to the 54th. You're not moving the decimal 54 places. All right, same thing goes for number 2, but this is a negative exponent. Negative exponents, remember, you're moving to the left now. All right, so if you have this beginning number and this base number right here, so now you're talking about 5.15 and a 6.35. So obviously, which one is greater? By the way, if you move it 4 places to the left, obviously, this is going to be the greater number. This one right here, you're moving another place to the left. So it's going to obviously make this smaller. And you really don't have to put it into standard form, but let's go ahead and do 1, 2, 3, 4. So now you have 0.000, that's 3, 5.15 versus 6, shouldn't have started there. Let me erase that. 6.35. Always start to the left a little bit because you know you're going to move to the left. You're moving 5. All right, so 1, 2, 3, 4, 5. And so now think about it. Look, I'm going to put this number here. So 0 point, and there's 1, 2, 3, 4 zeros now. 1, 2, 3, 4 zeros, and then 6, 3, 5. So, which is larger? This is greater. It's closer to 0. All right, so this is the greater number. That's basically what I wanted to kind of just take a look at. Now do that for the last 3, but try not to put it in standard form. Like look at the numbers and just see if you could kind of figure it out. And I'll pause. Well, actually, you have to pause the video, and then we'll come back and see if you got all of them correct. Yeah, all right. Here we go. So the first one, 2.56, going to the 5 to the right, obviously is going to be greater than 4.2 and moving to the left. So obviously the first one is greater, so I put the greater than symbol. 4.3 times 10 to the fourth is less than 1.6 times 10 to the sixth because you're moving 6 to the right. It doesn't really matter what this number is right there. Even like it's going to be um, 6 to the right, so that's the greater number. 7.1 times 10 to the negative second is greater than 2.9 times 10 to the negative sixth. You don't want to move, all right, you're moving 2 to the left with 7.1. If you move 6 to the left with 2.9, that is going to be the number that is less than 7.1. And that's really it. So this is all practice. We're gonna pause the page and there's a bonus round on the bottom. Do the whole page. We'll go over it. When you come back, we will have the answers down. Just make sure you understand that larger numbers are positive exponents, smaller numbers are negative exponents. We'll be right back. Okay, here are the answers. We have 2.39 times 10 to the fifth. We have, and by the way, I was doing this, I didn't mention this either. So when you count the spaces or the places that you are moving, you could I count in threes. So it's 3, 6, 7, 8. It's like, and it's just quicker. I don't know. You don't have to do that, but it's 4.5 times 10 to the eighth. This is 9 times. Number 3 is 9 times 10 to the seventh. Number 4 is 5 times 10 to the ninth, and number 5 is 3.507 times 10 to the negative fifth, because that's a small number. Remember, you're going to the right on that one. The decimal, this is a small number, so it's a negative exponent. So you have to move that decimal to the right to make a number between 1 and 10, which is 3.507. All right, same thing with number 6. You see the answer right there. Number 7 is 7.5 times 10 to the negative seventh. Number 8 is 8.7 times 10 to the negative ninth. And the bonus round, so much fun. It is 320,000 because you're moving the decimal to the right 5, and 9.75 you're moving to the decimal to the right 4, 97,500. 6.35 you're moving the decimal to the left 4, which is 0.000635. And then you have 8.27 times 10 to the negative seventh, and that's what you see right here, 0.0000827. And that is it. Next page. All right. So a lot of times they give you a number that is not in scientific notation. And this number right now is not in scientific notation. Remember, the coefficient in the front, the first number is the coefficient, right? So this number here, that 12.4, can't be 12.4. It has to be a number between 1 and 10. So there's different ways to do this, but by hand, it's pretty easy to deal with here. So you have a couple of steps that you're going to do. Obviously, to make this a number between 1 and 10, you have to move it over to the left. So it becomes 1.24. And since you made this number, this was 12.4, since you made it smaller by 1, smaller by 1, you have to make the exponent larger by 1. Right, so it's kind of like an opposite thing. If you move the decimal over to the left, 1, you're making that coefficient smaller. And since you made that smaller, to keep the number the same, you have to make the exponent larger by 1. So that's why I put a +1 there, and that's what it becomes. So I did want to show you before we move on, like I just think it's so easy to do by hand, but if you don't understand what I'm talking about right here, we're going to do a couple more. Obviously, you could always kind of do it on your calculator. And but the TI-84, these are the steps that you would have to take. So you're going to press mode. And when you press mode, um, if you don't have your calculator, go get your pause the video, go get your calculator. Make sure you have it next to you. All right, just for every lesson. But when you press mode, obviously what's blinking right there is normal. All right, and you have to go over to psi, SCI. All right, for scientific notation. Then you press enter, and you'll see it'll be there. Like if you go to the right, like now science fiction, scientific notation is like the one that's shaded. So now you press clear, right? And then say you put in something that is not in scientific notation, which is 12.4 times 10 to the third. And this is the way I like to put that in right there, like that. All right. As soon as you press enter, it's going to give you something like that. And that means, and just it's like a shorthand for scientific notation. So your calculator is so lazy that it's not displaying the times 10. So if it's in scientific notation mode, it's going to put the shorthand scientific notation down. And that shorthand scientific notation means 1.24 times 10 to the, and so like take a look at 1.24 times 10 to the exponent of 4. So it doesn't give you the times 10. Like say if I gave you 586, let's just say times 10 to the whatever third. All right. So 586. So like just to do that on like just to do that here first. 586 times 10 to the third by hand. All right. The decimal's here. So I'm moving it 1, 2 places to the left. I made the number smaller by 2. And I just kind of make that. So I put down SM2. I know that it's now 5.86. Since I made that smaller by 2, I have to add 2, making it larger, making the exponent larger. So it's 10 to the fifth. All right, so 5.86 times 10 to the fifth is the same thing as 586 times 10 to the third. All right, so let's just see what the calculator does. Going back to the calculator, if you press enter right now, all right, and it gives you 5.86 times, well, it's so lazy that it's not going to be times 10. All right, so with that times 10 to the exponent of 5. And that's exactly what we have over here. All right. So like there's ways that you can do it in the calculator. There's ways that you like, you can do it by hand. I prefer by hand, but if you're a little bit confused, use that calculator. The calculator will just remember every time you're basically taking something and putting it into scientific notation mode, you're pressing that mode, and guess what? Next time you use your calculator, if it's not in normal mode, it's going to give you all answers in scientific notation. And at that point, you'll remember, all right, let me just go ahead and go back to normal and press enter, and at least you'll be in normal and you can come back, right? Just one more thing that while I have the calculator going, all right, I'm going to go back into scientific notation mode, and I am going to put, which is really handy here, press clear. So you have 800,000. Like, is that 800,000? Yes, it is. That's 800,000. If I press enter, since I'm in scientific notation mode, it gives me the answer. So I mean, you could use your calculator basically for all of this. Right? So any number that is in standard form, any number that is in standard form, you could basically use the calculator. Look, 0.2356 8, blah, 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 blah. Press enter. That means 2.35688 times 10 to the negative first. I probably should have showed you that first, huh? Nah, by hand is great too. So, I mean, if you are in scientific, no, let's do another one with the calculator. If now this is 234 times 10 to the seventh, right? And I want to convert that to scientific notation. Guess what? I press enter. It's 2.34. Let me just get this over here. All right, so this is 2.34 times 10 to the ninth. And it makes sense. You move this decimal over 2, making it smaller by 2. You have to make this larger by 2. It's 2.34 times 10 to the ninth. So you know both ways to you know how to do it. The calculator, you're moving this over 1, making it smaller by 1. You have to make this larger by 1. 7.64 times 10 to the fifth. And you can type that right into the calculator and it will give you your answer. So we haven't really basically showed you with a negative exponent. The negative exponents are the ones that are a little bit difficult. Just remember, take it if you're doing it by hand. Just take it slow. You're making this smaller by 1. You have to make this larger by 1. So it becomes 1.24 times 10, and then negative 5 plus 1 is negative 4. Don't forget that. I mean, don't forget it. So, but you just use your calculator if you don't know what you're doing. All right. So this is the first one like this one that we've done. So you're moving this to the right now. This becomes 3.04. So you actually made a larger number. That's the first time. All right, large number by 1. So that means you have to make this smaller by 1. And that's when it gets tricky. A lot of students get this wrong. So you have negative 9 minus 1, that's a negative 10. But like I'm going to bring this calculator back up again, right? So if if you're a little confused, you're in scientific notation mode, you put in 0.304 times 10 to the negative ninth. Please don't put minus 9. Right? It's the negative ninth. And then you press enter and it'll give you the answer. It's 3.04 times 10 to the negative 10, to the exponent of negative 10. And that's basically it. So you choose what you want. You'll always have your calculator. So, just go crazy. All right. So this is like another explore. Again, I'm going to put this on pause. You have to basically tell whether or not this is in scientific notation or not. All right. So if it's in scientific notation, you put true. Because Betty claims all of these expressions below are in scientific notation. Betty is not right. Right. So if it is in scientific notation, put true. If it's not, put false and then correct it. So the first one, we'll do the first one together. And this is not, so this is false. So you could circle false. And you're just going to put this 1, 2, or use it, or your calculator, 4.76. This is making it smaller by 2. You make this larger by 2 times 10 to the 7th. Or use your calculator. You're going to pause the video right now, and you are going to finish this whole board. Use the calculator if you want. If not, do it by hand. And okay, so we're finished. Right, just use your calculator if anything. Put that in and then convert, and then just remember to put it in the mode in the scientific notation mode. You have to press mode, and you see mine is in scientific notation already. You press enter and it's in scientific notation. You want to check, just press to the right or left, and then but just don't forget to put it back in normal because that's what you're basically going to use all the time. And here are the answers, and boy, that is a lot of fun right there. You can't have much more fun than this. Yeah. All right. So, end assessment. go ahead, pause the video right now and do the problem and see if you could correct if it's which one is not written in scientific notation. Fix your answer so it is in proper scientific notation and pause now. So here we go. D is your answer. All the rest of them are in scientific notation. That first number is between 1 and 10. 6.73, 2.567, 5.555, and then 15.5 is the only one that is not in between 1 and 10. So I circled it, which one is not in scientific notation, then I corrected it on the bottom, and I did it by hand. If you do want to just flip up the calculator and just do one more, oh no. All right, if you want to do one more, I'm going to try that again. Uh, so you press clear and then you press mode first and you're in normal mode. You press enter, that's scientific notation mode, and then you press clear again and you put 15.5 times 10 to the fourth. All right. And then you press enter and it'll give you something like that. Don't freak out. It's 1.55 times 10 to the fifth. That's what we have down on the bottom, and that is going to be your answer. And I think that's it. If you have any questions, please get in touch with us. Put your, use Google Classroom to ask questions. Miss Gadget and I will be around, you know that. And you can get in touch with us that way or on Remind. Everybody at this point should be signed up for Remind. And that's the end of the lesson. All right. Thanks a lot for watching.